Hello, everybody. My name is Göttlicher. I'm a developer, and I've been working for SUSE for more than 8 years. The first time I came in touch with SUSE Linux was many years ago. I was working as a system administrator for a medium-sized company. We had 400 employees, 20 servers, and I was a system administrator, and I was responsible for these machines. Half of the machines was running old Unix. The other half was running SUSE Linux. It was so much more fun to administrate SUSE Linux. After that, I went to university, and we had a lab. Half of the computers was running Windows. The other half was running OpenSUSE. When I went to the lab, most times all the Windows servers were already taken by other students, and it was pretty easy to get a free one, a free SUSE machine. So there are different reasons why it's so much better to have a SUSE machine. For example, as you don't have to wait for it, or it's easier to administrate. But sometimes it's not that easy to administrate. So some of the obstacles that could occur to you are you set up your family's computer and your brother wants to install some software, screws up your machine, and then he asks you, can you please fix it? And when you say, well, okay, what did you change? Nothing. Okay, let's restore the backup. No, my changes! So probably you want to have some nice way to find out what has changed. Or you set up your workstation, everything's perfectly configured, and then you have your laptop and want to have it configured in a similar way. Another use case is that you want to upgrade from OpenSUSE 13.1 to 13.2, and you want to transfer your changes, your software that you manually installed, your configuration you adapted to your new machine. And the last use case listed here is that you are responsible for some machines in the lab in your university or in your company. You open a door and there's some old workstation. It's connected to power, connected to the network, but you don't know what it is for. You ask your system administrator, and he says, well, that was maintained by some guy. He left the company or the university some years ago, and you don't know, can I unplug it? Will I break it? Is it essential for the whole infrastructure? So you want to know what's this system's purpose. Well, I could tell you a lot about theory behind it, how to do it, but I want to show you a short demo so you know how it looks in practice. So you know this talk is called Machinery, and I will show you a tool called Machinery. It's a command line tool. I can call it. And what we want to do is we want to address this use case where your brother or my brother, actually I don't have a brother, but probably it was your brother who broke my workstation. So let's find out what has changed on this workstation. So I use Machinery, and I want to inspect this broken machine. This machine is called OS15. It's running OpenSUSE 13.2. That's why I came up with this host name. I will give this report that will be created, or let's call it system description, the name current. And I will also extract files. So what is going on now? This tool tries to get a lot of information from this broken system. It logs in using SSH. It retrieves the list of packages. It retrieves the list of software repositories, the users and the groups, the services, which means systemd and system5 init services. And it also retrieves some files which are unmanaged files. That's a list of files which were installed on the system not by RPM, but for example by tarball. And it also will retrieve changed managed files that are files which were installed by RPM, but were changed later on. So if someone adapts a script in user bin, that will be also figured out. And we also have configuration files which were changed. We will also get these files, so we will have an overview over this system. You have a question? It's a virtual machine running on my laptop, but it could be any machine which is accessible over the network. So what I have now is the system description of this broken machine. This nice tool shows me what the next step is. So I can have an overview over the packages, the users and the groups, and so on. What I'm interested in is what has changed in the meantime. And, well, I'm a lucky guy. I created such a system description when I set up the machine for your brother, because I don't have a brother, and I want to compare both system descriptions. So I call machinery compare and pass both system descriptions. Okay, what can we see? There's one additional package. It's called xbill. Does someone in this room know the software? Raise your hand. Okay. And we also see there's one configuration file changed and some libraries installed. But these files are unmanaged files, so they were installed not by RPM, but manually. So it seems as this evil brother wanted to install xbill, installed some libraries on the system, and maybe that's the reason why the system does not work exactly in the way how it's supposed to. That's one of the use cases. Another use case we had was this machine in the lab, which was abandoned. The administrator has left the university or the company, and we want to know more about this about the system. So what we could do is we could inspect such a system. Let's use the original system and have a look how it looks like. So this is a system description of some system. It shows which system, which operating system it runs. It shows the list of packages. Here are the packages, including the architecture, the vendor, the software patterns, as you know them from Zipper, the software repositories, users and groups, the services. That might be interesting to have a look in this in the services to see which services are delivered. And I told you earlier that there are different sorts of files. So we have a list of unmanaged files, the files which were installed not by RPM. Changed managed files, in this case they are empty, so no one hacked around on the scripts which were delivered by RPM. And also the configuration files. 3 of these configuration files were changed, and if we are interested in the changes, we can have a look at the diff. So what we see is that the 2 lines were added when I compare the original version, how it was shipped by RPM, to how it's right now. So that's how we can find out details about a system, what the purpose is, how it's configured. All that works with system descriptions. I used the term more again and again, so let's have a look what system descriptions are. Let's go back to the slides. So system descriptions are the essential central part of all the workflows. Such a system description contains all the data to replicate a system. So it contains everything to rebuild the system, so it also contains manual changes. So if I build an image using such a system description, I have functionally wise the same system. Such a system description can be stored. It can be compared, as I already showed you. It can be viewed on the command line or in HTML. And it can be imported or exported to other formats. So, for example, AutoYast or Kiwi. That means that this system description works together with other tools. In the center of all these operations is the system description and the system administrator. And around are different operations which work on the system description. So let's go through the different operations. Let's start at 9 o'clock at inspect. I already showed you inspect. It means we log in onto a running system. We investigate what's going on there, what's configured, packages, patterns, and using this, we create a system description. Next one, clockwise, is validate. At this operation, we have a template which describes how a system should be configured, and we compare it to our current system, and then we see, does it match the packages I want to have installed in my system, so I can use it for audit, or if I want to see if it's, if it fulfills the requirements for some application that some libraries need to be installed. Then we have show. That was already demonstrated. It's on the command line or the HTML report. At 12 o'clock, parameterize. Does someone in this room have an idea what it could mean? Except Cornelius, because Cornelius is my boss. He knows everything about machinery. So I think this question is not challenging for him. But does someone else know what it could be? What do you think? Any ideas? Okay, I will tell you. So you have a system description and you want to have some variables which you can set, for example, the host name, or if you have different environments like production environment and testing environment, you want to have some variables you can set. So that's meant by parameterize. Modify takes a system description and you can change certain parts, add some packages, change user passwords. So that's working on a system description. The next one is build. Building means I take a system description and create an image which can be applied on a hard disk or on a virtual machine or in the cloud. Then we have apply, which applies the settings described in system description onto a running system. Run is some sort of test drive. When I have a system description, I want to see, does that fulfill my needs? I can test drive it before I deploy it, which deploys the next step, where I could deploy to the SUSE cloud, for example. And then there's two very important ones. That's import and export, because that makes it possible to integrate machinery into your workflows, to work together with your tools like AutoYast. So we are able to export AutoYast, or we can create Kiwi, so you can build your images using Kiwi. Some of these operations are already implemented. Some will be in the future. But using all these different operations, you can, if you add them together in the right order, you can make your workflows. For example, if you want to migrate from physical to virtual or to the cloud, you can start with inspect as the first operation. Next operation would be build. You build the image. and then you deploy. So connecting these different operations fulfills your use cases. So it's machinery which works on this system descriptions. That's the tool I already demonstrated. It's a command line tool, and on the hosts, there's no client software needed. So you do not have to run a daemon which eats up your memory. You don't have to install some Ruby stack, Java stack, or whatever. So it only uses the tools which are on Linux systems like tar, rsync, find. The only requirement is this machine must be accessible using SSH. The architecture looks like that. We have an administrator machine on the one side, and then we have the targets which are administrated. So machinery is installed on the administrator machine, and supported is OpenSUSE 13.1, 13.2, /12, and Tumbleweed will be supported soon. And as the targets, which can be inspected, for example, we support OpenSUSE 13.1, 13.2, /11, /12, RHEL 5, 6, and 7, and Tumbleweed will be supported soon. There's the question. Yeah. Wow.
Machinery runs on those machines. What are the restrictions? What does it depend on?
Could you rephrase your question, please?
I would be. I want to find out what are the restrictions. Why does it run machinery only on those machines and not on a broader kind of machines? It has to SSH can use the other tools.
Yeah.
So what's the restriction?
Do you have some certain operating system in mind which you would like to see machinery to support?
Debian.
Yeah, there's one big difference between Debian and the systems listed here. It's a package manager. So right now we support these because they are RPM based. But with some effort, it would be possible to also support Debian-based distributions.
Okay, nice, thank you.
You're welcome. There's another question in the back.
So that's the operating systems that you support. What about architectures? Is it no arch, or are there specific architectural requirements?
We support the package itself is not no-arch, but it works on Intel, it works on System Z, it works on PowerPC. So I think your distribution or your architecture will be supported. And the inspected host itself are, it does not depend on the architecture.
Would it be to add an additional architecture?
Are you talking about the target system or about the system where it runs?
Both.
Okay, so I can give you the same answer for both questions. It's mostly about the testing environment. So we have tests which ensure that we don't have regressions, and we need to set up these machines in our infrastructure. That's the most effort. But the architectures itself, it's not that much work to support another architecture. As long as there's a Ruby stack for the administrator node, there's nothing which makes it hard to have this architecture supported.
Maybe as a follow-up to that question, is there anything specific to the bootloader used?
No. So right now the bootloader is not inspected. So your administrator node comes up, That means your bootloader needs to be installed properly. But I think if you run some software on some system, the bootloader works. And on the target systems, we don't inspect the bootloader because it's not the essential, the essentials of a system, because we look at a system from the point of view that we want to offer a service to a customer. So we inspect the systems from like a black box. So that means it's not hardware dependent what we inspect. And yeah, Tumbleweed is also shown here on the list, but in brackets there's soon. That's exactly why, an answer to your question, we haven't set up our test environment fully for Tumbleweed, but I expect it to be done by next week. And then I can remove the soon and brackets, and it will be for different architectures very similarly. Any more questions before we go to the next slide? So let's talk about the project itself. So the essential part is the system description. And we don't want to reinvent the wheel. That means we want to use tools which fulfill the purposes, and at the same time we want to work together so machinery can be integrated into other workflows. So we want to provide a toolbox. When we started this project, we decided that we want to work in an agile way, which means that we want to react to user needs quickly. So we have 2-week sprints. We listen to our users, we listen to our customers. So we want to find out what's the most important thing right now. So we implement the most important features first. And it's open source. If you want to have the code, we are on GitHub. GitHub, SUSE machinery. And we also have a nice homepage. In the top left corner, there's some links, which are one-click install links for OpenSUSE 13.1 and 13.2. And we have some more information about the project and the software on our homepage. So how can you participate? First of all, you can use it. You can tell us about your needs. For example, architectures, other operating systems. When you use it, you might find some bugs. Please report them. If you can send us patches, they are always welcome. You can write some documentation, or you can blog about how you use it, how you migrate it, how your 13.1 to 13.2, for example. And you can talk about it. Tell others that there's this software that might fulfill their needs. And there's one last thing how you can participate. You can ask some more questions. Are there any? There's the question. Could you please wait for the mic?
Test. Okay, if I want to find out, with your example, how my my sister screwed up the system, I would like to compare against the latest snapshot by Snapper. That's why I have it. So, but it seems you require a running system.
It's a different approach. So if you run Snapper, for example, then you need to have snapshots on your system, so that it depends on your file system. Or you could also use machinery.
I was wondering, are you inspecting also the user files or your user home directories, for example?
Sorry, I didn't get your question.
If during the system inspection, if you inspect not only the system configuration, but also user configuration, like user home directories and so on.
So it depends what you call configuration. What we call configuration is files which are marked as configuration file in RPM. So if there are files in your home directory, they are likely not to be marked as RPM files, as RPM configuration files. So they won't show up there, but they will show up, for example, as unmatched file if you inspect it like that.
Unmatched file, how do you inspect for if it because I expect that there will be numerous files under the some time long running system which aren't packaged anywhere, so you list all of them?
Well, there are different approaches. First of all, we can list all of them if they are in one directory. So a directory which contains files which are unmanaged, then we list the directory. And we can also apply filters. So if you see too many files and want to filter out some files because you want to have a better overview, then you can also apply filters before you show them. Any more questions? There's another question.
Could you tell more about technology? You already mentioned Ruby.
Yeah, so
your data storage, such things. Maybe
sure.
Maybe quick, maybe general.
Yep. So let's have a look. So our software is implemented in Ruby. So that means you need the Ruby stack on your administrator machine. And we store the system descriptions in the home directory of the administrator who runs the tool. You don't need to run it as root. It can be run as a normal user, but you need root access to the target machine. And they are stored in a directory .machinery in the home directory. And for example, this file contains all the information of the system description. So this JSON file is the system description. And there are also some directories, change managed files, config files, and unmanaged files. That's where these files are exported. So we have always a system description which contains all the data to replicate the system. You're welcome.
Is it possible to hook machinery up to an orchestration tool like Salt or something like that to fix any gaps?
That's exactly what we want to do. We want to fill the gaps, and there are already some sort of research how machinery could work together with Salt. But we don't want to narrow it down to Salt, but we want to make it to fit to different tools. But that's a good question, and yes, we want to work together with other tools and provide machinery as part of a toolkit.
Yeah, I see quite a similarity with approach. How do you relate to AutoYast, and what's the biggest difference between machinery and AutoYast?
So when it comes to AutoYast, we can export AutoYast. So for example, we can inspect a system and export AutoYast. That's one thing. And there's some differences in AutoYast compared to machinery's system descriptions, because system descriptions, they describe a system. So that's a description, while a AutoYast profile contains logics, like if there's more than one network card, make it a router. If it contains more than 5 disks, make it a storage. So AutoYAS profiles can have some logic in it, while the system description just describes the system. If there are no more questions.
I have one question myself. If I've understood you correctly, there's 2 ways that you can inspect the system state. One is by comparing the list of RPM files installed against any changes towards their configuration files, and the other one is by comparing to system description. Is that correct so far?
Yes, so we can create a system description which contains a list of files, different sorts. So files like configuration files, contains a list of packages, and also the files which don't belong to packages. So that's one system description. And then we can compare different system descriptions to each other. So, for example, 2 different systems can be compared, or one system at point X in time to point Y in time. So you can see what has changed over the time.
For that to work, you need to have previously executed the inspect step on that machine, like you mentioned for your virtual brother. Might it make sense to actually integrate that functionality into, say, the OpenSUSE installer or something, so that such system descriptions are saved automatically at a certain point in time, or to have like a package checked into OpenSUSE factory that contains, like, for a certain tumbleweed release, the set of packages that it is supposed to contain or something like that?
Yeah, that's this template approach. That might be a nice thing to have templates how certain systems should look like as a minimal requirement, so you can compare. And your other idea of having a system description created during installation is also a nice idea, like this clone the system for AutoYAS checkbox in the installer to have a similar checkbox for create a system description. Nice idea.
At the beginning, there's a use case that you have a desktop and you have some laptop and want to have the same systems on laptop.
Yeah.
How do you solve the hardware differences? For example, my desktop have common boot, but my laptop use UEFI, and I have on laptop some power management tools that's not on desktop, and such differences. So how do you handle
the current approach is more a manual approach. So you set up a machine, and then you want to find out what exactly do I need to configure. So this tool will show you the configuration files you need to port to your other system, and it will also give you the packages which you also want to install on the other host. If there are architecture changes or so, you as an administrator need to know what to do. But this tool will assist you with a lot of information which you could also find out on yourself with a lot of effort or with machinery very easily.
Thank you.
Questions?
So thank you, and if you have any more questions, I will be around. Just ask me.